3738, the determinants of inverse matrices. So let's go through this worksheet. Evaluate the determinant of each matrix. So remember, determinants is a special number that all square matrices have. It has to do with solving and stuff. So the easiest way to do that for a 2x2 is to go down diagonal, -4, minus the up diagonal, -1. So I get -4 plus 1, double negative, so I get -3. Alright, so down diagonal minus up diagonal is the way of doing that. So one right here, same idea, we're going to go down minus up, so -14 minus -14. So I get -14 plus 14, that's 0. That's actually a very special matrix, right? A 0 matrix means you cannot have an inverse, which we'll talk about more later. Next one, it's the same thing. So 30 minus 18, so 12. Now we could also do determinants, before I move on to the last one, you could also do determinants on your calculator. I mean 2x2, it's actually much easier to do by hand, but if you want to check your work. Second matrix. Now these matrices are, a lot of people ask like, how do you delete them? It's not worth the trouble. You have to like go into the system and like delete. It's not worth it. Just write over it. It's the easiest way to do it. Or just reset your calculator if you want. So 2x2 matrices 5, 3, 6, and 6. Right, and then you get out, go to matrix. Now I'm going to find a determinant, so I'm going to go over to the second column where it says math, and there it goes, determinant. Then you select your matrix, A, hit enter, and I just get 12. So matches. Again, for me, it took a lot more work than just doing it by hand. You actually also do it on Desmos, right? So you got to put a new matrix in. A new matrix of, there we go, 2x2, 5. Then I have to hit it here, 3, 6, and 6. So remember, you just put enter so that now it knows that what A is. And then over here you put determinant, and you press A. And you get your answer, 12. Again, so my way to stop you from using a calculator from doing on Desmos is to use this one, put a variable in there. So again, same idea, just go down minus up, don't get scared. So 12 minus -w. Two negatives make a positive, 12 plus w. There we go. Determine whether the matrices in these pairs are inverses. So remember, inverse matrices is when you multiply the two matrices together, and you get the very special matrix, identity matrix, which is 1, 0, 0, 1. Right? The diagonal should be 1, everything else should be 0. So that's how you know when to inverse. You get that particular matrix. It's the one of matrices, 2x2 matrices. So we just gotta multiply these two things. Like we know how to do that. So I'm gonna go 2x2, 2x2, so it should work. So these do match. You get a 2x2. So 2, 1, -1, 0. Alright, that's this all right here. 1, 2, 2, 1. And let's multiply these two. Alright, here's a space. Here's the space. Here's my 2x2 matrix. See right there. 2x2. So my other one right here, first row, first column. So I get 2 plus 2. And I got news for you. I already got a 4. So I'm going to stop there. These two are not inverses, right? To be inverses, you got to get 1, 0, 0, 1. I got 4. So no. My guess is the next one will be. So let's multiply those two. A little sloppier, but still same concept. So we're going to do the first one here. Row 1, column 1. So -1 times -1 is 1. Plus 0 times 1 is 0. So far looking good. The one right here, right? Row 1, column 2. So -1 times -1 is 1 again. 1 times -1 is -1. So that'll give me a 0. Top row, A-OK. Bottom row, 0 times anything is 0. Plus 0 times anything is 0. And then the last one here, right? So bottom row, column 2, so 0 plus -1 times -1, which is 1. So yes, we get that, and yes, they're inverses. So easy way to check if two things inverse each other is just multiply them. If you get the identity matrix, the diagonal 1 to diagonal 0, then they're inverses. If not, they're not. Now we want to find the inverse if it exists. Usually I get the formula here. I'm surprised the formula's not on there. Inverse formula is this: 1 over determinant of A. And you switch these two, so this would be dA. And you change the sign of these two, negative B, negative C. So that's the inverse formula. And I would give that to you on the quiz or test. Find the inverse of each matrix if it exists. So first gotta find the determinant. So down minus up. Negative 6 minus 0. So it does exist because I could fill out the formula now. It's going to be 1 over negative 6. Right, so the way it's, as you see that, right, the normal A matrix would be A, B, C, D. So that's what it corresponds to. So it's saying flip this diagonal there. So I got to switch these two. So this becomes 2 and that becomes negative 3. Then it wants you to switch the signs of these two diagonals. So 0 and negative 5. 0 you can't really switch, it's still 0. And then 5 becomes negative 5. So we get that. Now that's correct, but we want to write it as a matrix. So simplify down. So it should be just all in there. And I get negative 2, 6, or negative 1/3. I get 0. I get 5, 6, and I get 3, 6, or 1/2. So there we go. I could reduce these two, but that's good also. So that'll be the inverse of this matrix. You can double check your work. You can multiply this guy by this guy, and you should get the 1, 0, 0, 1. So let's do the same thing here. So first I'm going to find the determinant first. So I get 4 minus 4, which I get is 0. And that's not, I can't do a determinant on that one. I can't, oh, it's just that. I can't find the inverse on this one, right? Because it's 1 over determinant. That'll be 1 over 0. So that's undefined. So inverse. So if you get 0 in your determinant, your 2 by 2 determinant, you can't have an inverse. Actually, any determinant, actually. No inverse with that. Now let's talk about of determinants and inverse matrices. So it's really useful. You could solve equations using them. You're like, oh, 2 by 2 is easy. But eventually you get to like 3 by 3, 4 by 4. It's a lot easier to do with the matrix than it is to do by hand. And a matrix you use essentially a calculator or a computer program. So the way we do it's like this. So this is one way to do it. We wanted to separate out this equation here. So we have something called a coefficient matrix, which is just the coefficients of all these numbers. So think about this as like an X column, a Y column, and the answer column. Or I shouldn't say answers, the constant column. Right, so we want a coefficient matrix for that, for our X and our Y. So for coefficient matrix, we're going to put down negative 8 and 6 for the first column. And then for the Y column, it'll be negative 10 and 5. Like that. Then we have the variable matrix thing. So all that means is we're going to put a little matrix with our variables. Now, does X or Y go on top? It's all about the identity matrix. Look at the identity matrix. Right, on top, look what column that is. That's the X column. So top's going to be the X. And on the bottom, it's the Y column. So the bottom's going to be Y. So that's where it comes from. Now we need the constant matrix. So what's our constants? 24 and 2. Just like that. So now we have to set up. So what we have to do now is get rid of, well, if I want to solve for X and Y, we got to get rid of this guy. So what we're going to do is we're going to find the inverse of the coefficient matrix and then multiply both sides by it. So that's kind of going to be this thing. So let's find the inverse of the coefficient matrix. Now we don't do this by hand. We could do it by hand, but we can also do it with the calculator. So let's do, I'm going to show you on the calculator both ways. So let's do here first. Oops. I'm going to go second matrix. I'm going to type in both of those. Actually, not to say both of these. All of my equations right here. So coefficient matrix and a constant matrix. You don't put that one in because calculators can't do variables right now anyway. So 2 by 2, it is a 2 by 2. It is negative 8, negative 10, 6, and 5. So there's my coefficient matrix. And let me get out and go put my other matrix down there. This one's a 2 by 1, 2 rows, 1 column. We have 24. See, go check your work, make sure it's right. And 2. Right, it looks like a 2 by 1. So now my matrices are in there. So what they want me to do is, essentially what we're going to do is this. Let's say this is matrix A, X, and B. Right, so we have this set up right now. What they want us to do is this. Multiply the left side by the inverse of A. And these two would cancel out, you get the identity matrix. And you essentially just get X. And since I did it on this side, I gotta do the same thing on this side. So we're gonna multiply A inverse by B on that side also. Right? Whatever you multiply one side by, you multiply the other side by. So just to show you, let's get our matrix. Right, so let's get matrix A. The inverse, I should have shown this earlier, if you want to do it on the calculator, is you press the inverse button. That gets you the inverse of A. Just to show you its inverse of A, I'm going to multiply that matrix by A. Then it'll go the way I want it to. Let's do this. Enter. There you go. And then times that by matrix A. Just to show you it's the inverse. It is right. I got the identity. So that part cancels out, and you just get X. On this side, I can multiply that inverse by B. Now notice with matrices, it really matters how you multiply it, right? So you can't multiply the matrices AB does not equal necessarily all the time BA. So it matters. I did the inverse on the left side, I gotta do the inverse on the left side. Gotta make sure it's the same. So let's finish this. Let me erase that so we have some space. Let's do some of the calculator. So I'm gonna do A inverse times B. So just select the A inverse again. So second matrix, A inverse, then we're gonna multiply by matrix B. I get 7/8. Remember that equals X, but what does X equal? X equals just the matrix XY. So this is really just this. So we have our answer, 7, -8. So that's how you use a calculator to solve equations, so system equations. Now again, for a 2 by 2, like it's easier to do by hand. But when you get a 3 by 3, it's generally pretty easy to do much. It's just by a 3 by 3, it's already easier to do with the calculator. And then you get to 4 by 4 and 5 by 5, it's not even close. You can do with the calculator. Now let me show you how to do that. The same thing on Desmos, in case you want. It's the same idea. Let's clear this. Let's do a new matrix, and we can do our matrix A is going to be the coefficient -8, -10, 6, and 5. So I'm going to type that in there. And we have a new matrix of B. So it's a 2 by 1, 2 rows, 1 column. There we go. And 24 and 2. So we type it all in there. And then, if we want to get this, we just do the same way it says. We're going to do A. There's an inverse button right here. And then we're going to times that by B. And we get 7, -8. And I forgot the negative right here. So there we go. So you can also do this method on Desmos. Same concept. Now the next thing we cannot do on Desmos, that's reduce row echelon form. This is the fastest way, and the reason I'm showing you this, the fastest way to solve it by hand that I know of is to do reduce row echelon form. So right here, the way we do, we got to first set up as an augmented matrix. You'll learn more about that in linear algebra. For now, I'm just going to show you that it is, you write the whole matrix together. Right, you write the identity matrix with the constant matrix, and you just separate with a little dash line so you know, okay, this is the constant, this is like my solution is going to be, and this is my X, and this is my Y, right? It's like X, Y, and constant. So we're going to put that all into our calculator. So again, now, as a you can do not do this on Desmos, you can do this on the calculator. But we're going to go second matrix, we'll go over to edit. I got to make a big old 2 by 3 matrix, so it's 2 rows, 3 columns. And then it's 3, 1, 3, 5, 3, 6. So it's a big old 2 by 3 columns, and get out. And then the easiest way we're going to solve is called reduce row echelon form, which is a method we haven't learned yet. The only reason I'm showing you it's honestly the easiest way of doing it. So you go second matrix, go to math, toward the bottom, and press up because that's the easiest way to get to the bottom. Is row echelon form and reduce row echelon form, and that's the money one. So you hit that one, then you select your matrix, 2 by 3, hit enter, and it gives you this. Right. So what it did was you found the identity matrix here, doing some row operations, and you got what the identity. You made this side had the identity, and this side here is your answer. So we got 1001.75, 0.75. So this means, just like before, our x is 75.75, and our y is 0.75. And that's how you reduce row echelon form. Why did I do with that equation? I should have done the exact same equation. But live and learn. So then all this is here is solve any method you want. That's all the second page is. Right, so if we're going to solve any method I want, I would do reduce echelon form, reduce row echelon form. But I'll do reduce row echelon form for the first one. I'll do the identity one for everybody else that doesn't have a calculator. I'll do it the other way. So the first one, I'll do reduce row echelon form. Wow, it's hard for me to say. So we're gonna go matrix, matrix, second matrix, edit. And then this is a 3 by 4, 3 rows, 4 columns. I gotta type all these in there. Oh, that's probably the worst part of all of this, is that the whole row in. I'm trying to go fast, but still it's tedious. Something much faster to do by hand. I mean, hand in the calculator, not hand, like do the math by hand. Because I don't want to do it with negative 85, that's crazy. Okay, so it's all in there, right? Really don't want to do this by hand. So now we're going to go second matrix. We're going to go to math. We'll go towards the bottom where it says REF. Second matrix. Select my matrix. Hit enter. Look at that. Right? X equals negative 3. Y equals negative 4. Z equals 6. Calculator programming for the win. Right? So that's so much easier to do now by hand. By hand with the calculator. Using matrices. So that's reduced row echelon form. On this one, I'm going to do it with the identity because not everybody has the calculator, so I'm going to do it using decimals, essentially. So remember, doing decimals, that's the one we did. We'd write this. AX equals B, and essentially to solve it, you do inverse of A times B. So let's write out AX times B. So my A, right, it's a coefficient matrix, so you want, it's like X, Y, Z. My X here is 1. This one does not have an X. When it's missing an X, you put a 0. And then a 1 at the bottom. This one has a 1 also. Now you go to your Y's. This has a 2. This one has a 3. And this one has a 6. Now you go to your Z's. This one doesn't have a Z, so 0. Anytime it's missing, you put a 0. This one has a negative 4. And the last one has a 1. Just like that. By the way, it's the same thing if I did REF method. It'll be the exact same concept. Anytime it's missing something, just put a 0 for the matrix. Then for here we would have X, Y, Z. Again, why is it X, Y, Z like that? Again, for an identity matrix, it would be 1, 1, 1, 1. It comes from identity. And then 12 would be, my constant would be 12, 25, 20 for my B. Alright, so I have all that in. All I gotta do is put this into my decimals, so it's clear. New matrix, I need a 3 by 3. And then it's 1. Don't put enter. Don't. Man, 3 by 3. So it's 1. I gotta hit this every single time. I'm gonna change the number. I was hoping to go faster. That is 0. If I just leave it there, I think I could leave the zeros alone. By default, they just go to 0. 1, 6, 1. Again, this is so much faster to do by hand. So that's my A. Then I'm gonna do my B. Now for my new matrix B, that is a 3 rows. It's a 3 by 1. 3 rows, 1 column. If you're not sure, just play with it and I'll show you if it works out or not. So 12, 25 and 20. There we go. Now again, if I want to hit this, I just gotta remember that. So what I start off with, how do you solve for x? You take the inverse of both sides. Now again, it has to be the inverse on the left side inverse. So it'd be a inverse, look at that, inverse, times matrix B. And there we go. Our answer is 6, 3, negative 4. So that's how we do this with a calculator. Or with decimals, which is an online calculator. And we got 3 more. Again, I'm gonna do all of them. So let's do it all real quick. I'm gonna do all the rest by decimals. So you do RF if you want. This for the key here. I'm gonna do decimals. 0, there's no z on that one, and then 0, negative 3, 1. Right. Make sure that if you don't have the variable, it's a 0. Right. So you don't just follow. So this is x. It's x, y, z. So this one didn't have an x, so 0 there. This one didn't have a z, so 0 there. Very important. So my a, my x would be x, y, z, and my b would be the constant, or I was thinking about solutions. And lots of negatives. So negative 14, 14, negative 10. Get my decimals back up. Clear. And just type it in. New matrix. Always starts at 2 by 2. 3 by 3. And then some type them in real quick. So 4, negative 4, 2, 4, 2, negative 3, and 1. Done. New matrix. Put my constant matrix as a 3 by 1. There we go. So negative 14, 14, and negative 10. Hit enter. Again, all we're gonna do is how would I solve ax equals b? Gotta do the inverse of both sides. These will cancel out, and you get a equals a inverse times b. That's the key. So get a, hit the inverse, then times it by b. Ooh, there's an error there. This matrix doesn't have an inverse, so this right here is not possible. You get error. So not possible, no inverse. No solution is the more correct answer. All that work and then no solution. I was wondering why I was like, there's a little question mark. So you get no solution here. This is a identity, that's how I say it. This has a determinant of 0. So it's a singular matrix, we call that. So no solution. So that's what happens when it doesn't work. Same thing on your calculator, say no solution. Not possible. All that work for that. Anyway, next one. Same idea. Now notice it's only a z, so it's going to be 0, 0, negative 3. And then the second row is going to be 2, 1, negative 2, negative 6, negative 3, and 0. No z on the last one either. Oops, sorry, x, y, z. And then my constant matrix, b, that would be 6, 6, negative 6. Right, so notice that only has the z, so 2 zeros, then the z. That's a 2, by the way. Sorry for my bad writing. And then the bottom row has no z, so let's throw there. And again, we're just going to put it in our calculator, or I guess in my case, I'm putting decimals. So clear, new matrix. It's a 3 by 3. Thanks, decimals. 0, 0, 0, so negative 3, 2, 1. I wish there was an easier way to switch between matrix entries. Negative 2, negative 6, negative 3. If I use the arrows do it. Yeah, the arrows do it. Nice. And 0. Okay. So let's find the inverse of that. So a inverse, and again, singular matrix. So the inverse of this, the determinant of this is 0. So that's why it has no inverse. So again, no solution. So 2 no solutions in a row. What a worksheet for us. So the next one, this one actually is important. if I want to do split in the calculator, it has to be in the proper notation. Notice that it's not like in standard form, right? It has to be in standard form like you have here. This is not a standard form. So the first thing I do if I want to put this in the calculator is put in standard form. So over here, I gotta move the 3z over. So 3x minus 3z equals -1. Actually, I can move the 3z over and I can move the 1 over, which makes that a +1. Right, so +1 on both sides, subtract 3z on both sides. 2, I'm not gonna mess with it. It's the right, I'm just gonna rearrange it. I'll put the equals 4 on this side and rearrange it, but it's already in standard form, technically. I'm just gonna make it look nicer. Right, so I just kind of rearranged it, thus moving, I didn't move stuff over to the equal to sign. This one I gotta move the 10y over, make sure that's a -10y on both sides. So again, you want it standard form first. So you have to put in proper notation, put in standard form. And then now you can put in your calculator. Now, or in my case, decimal. So far it's been lots of no solutions. I'm hoping this changes it. Clear. Because it's so exciting to see me enter in matrices. It's a 3x3 again. It is 3, 0, -3. Diagonal pad works really well for this. 6, so much faster. -2, -10, and 6. Before I do anything, let's check if it actually has an inverse. Yes, it does, so you can actually do this problem. Nice. I don't want to hit clear, because it clears the A also. So let's put matrix B in. Oops. New matrix. This is going to be a 3 rows, 1 column. And then we're going to type in 1, 4, and -7. There we go. So you have a matrix in there. So remember, all we're going to do is, this is A times X equals B. Probably done right here. A times X equals B. We want to get rid of the A, so we're going to multiply both sides by A inverse. X equals A inverse times B. That's all we're doing. So on our decimals, we're going to type that in and go, okay, A inverse times B. And that's my answer. Not the nicest looking answer, but essentially that's essentially 0. It's 0.000. It's instead 0. 0, 1/2, and -1/3. There we go. That's our answer. I mean, it shouldn't be X, it should be X, Y, Z. So 0, 1/2, -1/3. Alright, so that's essentially 0. You can see it's such a small number. It's a program, so it's just running a computer simulation, so it's not, it should be 0, but it's close enough. 1/2, and then -1/3. Okay, last couple. So this is a determinant of a 3x3, which now it's like how far they don't teach how to do by hand anymore. It's on the state standards. So if you see this, we're going to do it with the calculator. You just do it the same way you always do it. Again, I've been using decimals. I will just use decimals for people who don't have a calculator. All we're going to do is type in a 3x3 matrix. So that's a 3x3. You can only do a determinant of a square matrix, which is one that looks like squares, where it's the same, row and columns are the same. So type all this in. So 5, 3, 3, -4, -5. So much easier with the D-pad. 5, 3, 0. Okay, enter. Then I want to find a determinant. So hit determinant, and then press my matrix, which in that case was C. Sorry, C. And I get my answer, 39. There we go. And then this one, they want you to find a determinant of these two and add them up. I'm going to use by hand because they're 2x2, so it's easy. So remember, down minus up. So it'll be 4 minus 6, which would get me -2, plus down minus up. So 30 minus -4. Double negatives make a positive, so 34. So I get -2 plus 34, which is 32. That's the worksheet.